Alright, vintage computer friends. Looking at my setup, you might already get an idea what's coming next. And indeed, the impossible feat has been pulled off for this extremely limited 1985 science fair microcomputer trainer from Radio Shack. The recursive version of the Towers of Hanoi has been implemented. And to my embarrassment, I have to say that it wasn't me who wrote this, I would say, most ingenious and most impressive program ever written for this extremely limited machine, but it was Jason. Remember that in my last video where we looked at programming the science fair, I mentioned that Jason had reached out to me in response to my first video to set the record straight, because I had some inaccuracies in the video. For example, claiming that the science fair microcomputer was released in 1976 when it was actually released in 1985, and so on. And in that same email exchange that I had with him, I also presented my task of trying to implement the recursive version of the Towers of Hanoi on this machine, and that I was kind of stuck because I didn't succeed in fitting the program in the very limited memory space, right? And then, Jason said, "Oh, you really nerd sniped me nicely there, right?" And he got to work, and 2 days later, he actually presented me with this fully functional implementation of the Towers of Hanoi, which only uses 80 nibbles, so it fits in the memory, right? And so he basically spent a great deal of time and ingenuity on fitting this original version that I had prepared, but where I failed, rewriting it, optimizing it, and also using some techniques which I was not aware of, like, for example, one special system call that was then able to save another few nibbles that just did the right thing for the task at hand. And yeah, I'm utterly impressed by this program, and that it is actually running on this little computer now. And I'm going to demonstrate his program to you. Meanwhile, Jason has also been added to the Hackaday IO page for this project. And so he was so kind to accept my invitation to the project, and he wrote a log entry, right? So you can find his program, the source code, on the Hackaday page, and also a very great explanation of how he actually achieved squeezing this into the memory, what kind of rewritings and optimizations of the assembler code he implemented in order to fit that in. But so I'm not going to explain the program to you in detail. Please have a look at the Hackaday page, right? And given that he's the author, he's of course also more qualified to explain this to you. And so we are simply going to execute it. First, it uses a stack in the memory region starting at address 50. You see that this is the ABC, the pack names basically. At address 50 there's the from pack, then there is the destination pack, and then there is the spare pack corresponding to my setup here, right? And also the first return label using the same technique that I use for the microtronic, right? So 0. And then we also need to initialize the Z register, which is at address 6B. Put in the number of disks you want to play with, and also the Y register needs to be initialized with 3. Okay, and then we are basically good to go, and the program does not start at address 00 but at address 17, and he did this in order to optimize the number of jump instructions that are required for the program, right, to maximize basically the potential for fall through. Basically just keeps the program going without having to jump, right? And the jump is expensive because it always requires 3 nibbles, and memory space is scarce and precious. So that's one of the techniques that he used in order to minimize the number of nibbles required to fit it in. Okay, so address 17 is set, and now we hit to run. And now the program has halted. When this bit pattern occurs, it is now basically waiting for us to interrupt it. And the only way of interrupting is now to hit the reset button. But it preserves the memory state as well as the registers. And we can now look at the memory space to see what the next move is. So we stopped the program, and now we have to look at the content of the Y register, which is register 6E. And that gives us an idea where the stack currently is, right? And it shows 8. And that means, given that the stack starts at address 50, we have to look at the stack frame now corresponding to this recursive call invocation at address 58. So we are inspecting address 58. And there we now find our first move. So we are going to move the topmost disk from pack A to C. Let me do that. Alright, so the first move was executed. And then we can continue the program, this time doing a reset and starting from address 00 as usual. Okay, and there's the next move. And we do the same thing. We look at the register, and this time we find that the stack frame is at address 54, and there we find the next move from A to B. Same game. Stack frame starting at 58 again. And now we are moving the disk from C to B. Stack frame 50. And we are moving from A to C. From B to A. Next move. Stack frame 54. From B to C. Well, and now there's only one move left. I don't think it will mess the last move up. Mess up. No, it doesn't mess up the last move. No. Again, stack frame 58. And we're moving from A to C. Wow. Yeah, it did it. But now it needs to terminate actually and figure out that it's done. So let's see what the next move will be. And now notice there is a different bit pattern, and that actually indicates now that the program has terminated and did its job. Well, yeah, what can I say? I'm utterly impressed, and I think that's probably the most impressive program that has ever been written for this little computer by Jason. And he succeeded where I failed, right? Because I would have needed 16 more nibbles or so. But he used very clever optimization techniques and his extensive science fair experience and knowledge to fill it in, right? And looking at the science fair manual programs, you know, you won't find anything like this in the manual. All of these programs are basically counters and binary to hex conversion and addition and multiplication, so basic arithmetics and some simple games and so on, right? Like Simon but nothing that would demonstrate how to implement recursion or really max out the machine, unlike this program, right? So, alright guys, thanks for watching. So please stop by, at the Hackaday project page if you want the details about this engineering marvel, and check out Jason's log entry there. I think that's probably the last entry video about the science fair microcomputer trainer from 1985. I hope you enjoyed watching it, and until next time on my channel, see you, take care, and bye. Thanks for watching.